Now that we've looked at the platform stack, let's look at different types of platforms and their business model configurations. On some platforms, the network layer is more dominant than the other layers. For example, marketplaces like eBay and Airbnb have a highly active network layer, consisting of the buyers, sellers, and the goods or services that are transacted through the platform. Similarly, social networks like Facebook and Twitter have a dominant network layer. Classifieds businesses like Craigslist and some online forums focus almost exclusively on this network layer with very little value creation at the infrastructure and data layers. A platform that is network dominant usually gains adoption by launching in a community of high usage. Think of Facebook launching at Harvard University, or Twitter launching at the South by Southwest conference. Platforms that are network dominant and need to gain fast traction in the network need to launch in communities of high usage. On some platforms, the infrastructure layer is dominant. These platforms create sophisticated tools and services that enable new forms of value creation. For example, platforms like Android and iOS are infrastructure dominant. These platforms provide the developer toolkit and the App Store tools and processes that are required to create, host, and monetize third-party applications. Content hosting platforms like Vimeo, the video hosting platform, are also infrastructure dominant and provide the video hosting and streaming capabilities as part of the infrastructure layer. Blogging platforms like WordPress may only provide the infrastructure layer where content can be hosted with relatively low focus on the network and the data layers. In contrast, a blogging platform like Medium combines blog hosting with creating a network of blog readers and writers and uses data to match relevant posts from the writers to the readers. Platforms that are infrastructure dominant need to get a community of content creators or developers around them to use the infrastructure and build value before network effects can be created. Hence, these platforms almost exclusively focus on getting producers on board first. Most app development platforms have extensive developer relationship management programs. Content platforms like YouTube incentivize high-quality content creators to come on board. Finally, the third and increasingly most important configuration is that of a data-dominant platform. The data layer plays an important role on every platform. Facebook uses data to fashion news feeds, Airbnb uses data to match hosts to travelers, but on certain platforms, the data layer itself constitutes the key value created on the platform. Industrial internet platforms like GE Predix, Siemens MindSphere, and Schneider Electric's EcoStruxure are examples of data-dominant platforms. Machines embedded with sensors constantly stream their activity data into the platform, and the platform aggregates data across all of these machines to create intelligence about larger industrial processes and systems constituting these machines. The platform also helps each individual machine learn from other machines and in this way provides network-wide intelligence. Application developers, field service professionals, and end users join in at the network layer, but the vast majority of value is actually created at the data layer. Amazon's Alexa is another example of a data-dominant platform where multiple smart home devices connect to the platform, share their data, and build complementary skills on Alexa. Many platforms in healthcare are data-dominant platforms because it's very difficult for one single firm to own the patient's data across the continuum of care. Hence, platforms like Philips HealthSuite partner with other data providers to create deeper intelligence by combining their data flows and co-innovating to create new services. Data platforms function like a pool into which different sources bring data and from which different sources extract insights. Data-dominant platforms gain adoption when they succeed in digitizing a critical form of data that is widely required by other ecosystem actors. In the construction industry, for example, the digitization of the actual construction project allows designers, contractors, and building operators to organize around a construction platform. In the medical industry, various actors organize themselves around a platform which has patient data, and so we see electronic health record companies going after digitizing the patient data. X-ray machine manufacturers are similarly looking to use digitized imaging data from their devices and organizing an ecosystem of actors around it who bring in complementary data to create greater insights on the patient condition. So what's important with a data-dominant platform is that we need to identify the central most important element of data around which a whole range of ecosystem actors can organize themselves. We've looked at 3 configurations here, but platforms can take any number of different configurations. For example, an industrial internet platform like GE Predix is data dominant because it creates value by aggregating data from various machines and sources and creating greater intelligence by linking and analyzing this data. But it also needs to invest heavily at the infrastructure layer to create the tools and services required to analyze and serve this data and to host application development and open innovation. Moreover, it also brings on several actors at the network layer, including app developers, field service professionals, system integrators, system designers, and even end users in an industrial setting. This is why the platform stack framework is so powerful. Instead of creating strict platform categories, it provides a simple and extensible framework to analyze different platform configurations. Platforms do not have well-defined bounded categories. Development platforms build out marketplaces. Marketplaces open up APIs for developers to create a developer ecosystem. And social networks can build out and license a data platform based on the data collected from social network activity. So platforms are not strictly categorized into specific verticals. They are best represented as different configurations of one stack, and their evolution over time can also be demonstrated with the stack.